easy flicker, that is an unsteady movement of a flame or light that causes rapid variations in brightness. Flicker, that is another topic under analysis and synthesis of television picture. Although the rate of 24 pictures per second in motion pictures and that of scanning 25 frames per second is enough to cause an illusion of continuity, they are not rapid enough to allow the brightness of one picture or frame to blend smoothly into the next through the time when the screen is blank between successive frames. This results in a definite flicker of light that is very annoying to the observer when the screen is made alternately bright and dark. This problem is solved in motion pictures by showing each picture twice so that 48 views of the scene are shown per second, although there are still the same 24 pictures frames per second. As a result of the increased blanking rate, flicker is eliminated. We have interlace scanning. In television pictures, an effective rate of 50 vertical scans per second is utilized to reduce flicker. This is accomplished by increasing the downward rate of travel of the scanning electron beam so that every alternate line gets scanned instead of every successive line. Then, when the beam reaches the bottom of the picture frame, it quickly returns to the top to scan those lines that were missed in the previous scanning. Thus, the total number of lines are divided into two groups called fields. Each field is scanned alternately. This method of scanning is known as interlace scanning. It reduces flicker to an acceptable level since the area of the screen is covered at twice the rate. This is like reading alternate lines of a page from top to bottom once and then going back to read the remaining lines down to the bottom. So this is the two fields. This is the two frames divided into, this is the frame divided into two fields. We have the first field and the second field. This is the beginning of the first field, and this is the end also of the first field. This is the beginning of the first, this is the beginning of the second field, and this is the end of the second field. In the 625 line monochrome system, for successful interlace scanning, the 625 lines of each frame or picture are divided into sets of 312.5 lines, and each set is scanned alternately to cover the entire picture area. To achieve this, horizontal sweep oscillator is made to work at a frequency of 15,625 Hz, 312.5 times 50, that is equal to 156 or 15,625 Hz. 50 is the vertical scan per second. That is to reduce flicker. Is the vertical scan per second that is utilized to reduce flicker. To scan the same numbers of lines per frame, 15,625 over 25, that is equal to 625 lines. But the vertical sweep circuit is run at frequency of 50 instead of 25 Hz. Note that since the beam is now deflected from top to bottom in half the time and the horizontal oscillator is still operating at 15,625 Hz, only half the total lines, 312.5, that is 625 divided 2, get the scan during its vertical sweep. Since the first field ends in a half line and the second field commences at middle of the line on the top of the target plate or screen, the beam is able to scan the remaining 312.5 alternate lines during its downward journey. In all then, the beam scans 625 lines, that is 312.5 times 2 is equal to 625 lines per frame at the same rate of 15,625 lines, that is 312.5 times 50, 15,625 per second. Therefore, with interval scanning, the flicker effect is eliminated without increasing the speed of scanning, which in turn does not need any increases in the channel bandwidth. It may be noted that the frame repetition rate of 25 rather than 24 as used in motion picture was chosen to make the field frequency equal to the power line frequency at 50 Hz. This helps in reducing the undesired effects of hum due to pick up from the mains, because in such effects the picture stays still instead of drifting up or down on the screen. In the American TV system, a field frequency of 60 was adopted because the supply frequency is 60 Hz in USA. This brings the total number of lines scanning per second 525 over 2 times 60. That is equal to 15,750 lines, to practically the same as in the 625 lines. Wave scanning periods. The wave shapes of both horizontal and vertical sweep currents. As shown there, the retrace times involved both horizontal and vertical are due to physical limitations of practical scanning system and are not utilized for transmitting or receiving any video signal. The nominal duration of the horizontal line is 64 microseconds, that is 106 over 15,625, that is approximately 64 microseconds, out of which the active line period is 52 microseconds and the remaining 12 microseconds is the line blanking period. The beam returns during this short interval to the extreme left side of the frame to start tracing the next line. Similarly, with field frequency set at 50 Hz, the nominal duration of the vertical trace is 20 microseconds, that is 1 over 50 is 20 microseconds. Out of this period of 20 microseconds, 18.72 microseconds are spent in bringing the beam from top to bottom, and the remaining 1.28 microseconds is taken by the beam to return back to the top to recommence the next cycle. Since the horizontal and vertical sweep oscillators operate continuously to achieve the fast sequence of interlaced scanning, 20 horizontal lines, 230 microseconds over 64 microseconds equals 20 lines get traced during its vertical retrace interval. The 40 scanning lines are lost per frame blank lines during the retrace interval of the two fields. This leaves the active number of lines for scanning the picture details equal to 625 minus 40. That's equal to 585 or 585 instead of the 625 lines actually scanned per frame. We have the scanning sequence. This scanning sequence, complete geometry, this is the complete geometry of the standard interlace scanning pattern. Note that the lines are numbered in the sequence in which these are actually scanned. During the first vertical trace, actually 292.5 lines are scanned. The beam starts at E and sweeps across the frame with uniform velocity to cover all the picture elements in one horizontal line. At the end of the trace, the beam then retraces rapidly to the left side of the frame to begin the next horizontal line. Note that the horizontal lines slope downwards in the direction of scanning because the vertical deflecting current simultaneously produces a vertical scanning motion, which is very slow compared with horizontal scanning. The slope of the horizontal trace from left to right is greater than during retrace from right to left. The reason is that faster retrace does not allow the beam so much time to be deflected vertically. After line 1, the beam is at the left side readily to scan line 3, omitting the second line. However, as mentioned earlier, it is convenient to number the lines as they are scanned, and so the next scan line skipping one line is numbered 2 and not 3. This process continues until the last line gets scanned half when the vertical motion reaches the bottom of the raster or frame. As explained earlier, skipping of lines is accomplished by doubling the vertical scanning frequency from the frame or picture repetition rate of 25 to the field frequency of 50 Hz. With the field frequency of 50 Hz, the height of the raster is so set that 292.5 lines get scanned as the beam travels from top to bottom and release point B. Now the retrace starts and takes a period equal to 20 horizontal line periods to reach the top mark C. These 20 lines are known as inactive lines as the scanning beam is cut off during this period. Thus, the second field starts at the middle of the raster and the first line scanned is the second half of line number 313 or 330. The scanning of second field starting at the middle of the raster automatically enables the beam to scan alternative lines left unscanned during the first field. The vertical scanning motion otherwise is exactly the same as in the previous field, giving all the horizontal lines the same slope downwards in the direction scanning. Back at point A, the scanning beam has just completed with fields for one frame and is ready to start the third field covering the same area as scanned during the first field. This process is continued at a fast rate of 50 times a second, which not only creates an illusion of continuity but also solves the problems of flicker satisfactorily. Thank you and God bless.